So we're going to look at a area problem from 2013. We are given two equations, f of x and g of x, and it says let R be the region bounded by the graph of f and g. It says find the area of R. So in order for us to find the area, we have to know which one is the top equation, which one is this, and which one is this, which one is the second one. So as we look at the two equations, we see the f of x is a quadratic equation. So that means the graph of this is going to be a parabola. So the bottom one is f of x. So I can draw on my screen right now and record. But yeah, so the bottom one is f of x and the top one is g of x. So in order for us to find the area, I'll choose a different color, black. So we're going to take interval from 0 to 2 because those are the two intersections. And for top equation minus bottom equation, so 4 cosine 1 over 4 x minus 2x squared minus 6x plus 4 dx. So we take the antiderivative of this and we get 4 sine of 1 x, and then we're using the chain rule, we get 4 over pi, and then for this we get plus x squared plus 4x. So here we have our antiderivative, and now we're gonna plug it in. So we know that once we plug in 0, it's just gonna be 0. But once we plug in 2, it's gonna be 4 sine of 1 over 4 pi 2 times 4 over pi minus, in here I wrote 2 over x, it's supposed to be 2 over 3, okay. 2 over 3 to the power of 3rd plus 3 times 2 to the power of 2 plus 4 times 2. This whole thing minus 0. And we can leave this at this state. We don't even have to solve it because this is a no calculator problem. So we'll just leave it at this, and this is the correct answer. This problem has 3 points, 1 for the interval, 1 for the antiderivative, and 1 for plugging in. So B says write but do not evaluate an interval expression that gives the volume of the solid generated when R is rotated about the horizontal line y equals 4. So we have to find the volume of the solid when it's rotated about the horizontal line y equals 4. So we're going to use the formula we learned in class, which is volume is the initial condition, the first intersection, the second intersection, and then pi, and then there's your number minus f of x square minus your number, whatever number they've given you, g of x square dx. So in here our initial, our first intersection is 0, our second intersection is 2, and I'm going to bring the pi in here. Okay, what is this? This is pi, and then our number is 4. So 4 minus 2x squared plus 6x minus 4 whole square minus 4 minus 4 cosine of 1 over 4 pi x times pi x. And don't forget the square, then dx. So this is where we're going to stop because all we have to do is write the equation. C, since the region R is a base of a solid, for this solid its cross-section perpendicular to the x-axis is a square, right? But do not evaluate an integral expression that gives the volume of the solid. So the volume of the solid is a square, so we have to find the volume of the square. So as usual, we use the formula for the volume of a square, which is the intersections. Take the integral of the from the first intersection to the second intersection, and then the top minus bottom square. So g of x minus f of x squared dx. And we know g of x is 4 cosine x minus 2 x squared minus 6x plus 4, the whole thing square dx. And there's your answer to C.